Welcome everyone, thank you for joining us for lesson 12. We're going to be covering some interesting stuff today and build on what we have learnt in previous lessons as well. Okay, first off, a bit of project talk. As discussed last week, we expect you guys to do a project for this half of the course. We've got enough theory under our belts that you can do something quite amazing now. So, as we also discussed, you need to choose a partner, because for most of you this project will be done in groups of 2. So please make sure you've chosen a partner and that you can get together with this partner to work on your project. Also, it's now a good time to start thinking of what idea you want to use as a basis of your project. As we discussed, there are a lot of examples on the Scratch website that you can go and have a look at. We will be judging your project on 3 things, mainly originality. Is it something new that we haven't seen before? Code use. Are you using the correct code blocks to get what you need to do? And also neatness. Okay, we want things to look neat. It doesn't mean you have to be an artist to draw your own sprites. There are plenty of places to get sprites from on the internet, and if you need help from us to do that, please contact us and we'll help you out there. Also, it is a very good idea to start on your project. Even if you're not 100% sure what you want to do, start practicing what you've already learned. Because if you leave it too late, you will run out of time, because the course does end just before year-end exams. Last time, we looked at the ask and wait block, which you can see down here, which we used to get input from the user. We also discovered relational operators, which are the less than, greater than, and equals to operator, which you may have covered in maths already. And we also covered the join operator, which we use to join 2 strings together, or a string and a variable. And we also looked at using the mod block or modulus, which gives us the remainder of a division sum, which we use to figure out if a number was divisible by 2. We also had a look at 2 very other important blocks called the if block and the if else block, which are also known as decision blocks, which are used widely in all types of programming to make things happen the way they should. We also started on the Polygoner program. In the video version of lesson 11 we finished it. In the class lesson we didn't finish it, so if you watched the video you would have gone through it all. And if you attended the class, we only finished it in lesson 12. And as always, we have our supplementary lesson material on our lesson pages on our website, which also includes links to our videos which we host on YouTube. Today's goals, we only have 3. The first one is to finish figuring out how Polygoner works. As I said, in the video version we did complete it, but we will go over it again briefly in this video. We're also going to learn how to use the AND block, the OR block, and the NOT block. And then we are going to go over how Up Tera works, which was one of the programs we gave to you in lesson 10 to try and test how much you've learnt in the course so far. Okay, back to Polygoner. As discussed, we have got 2 variable monitors on the screen, sides, which tells you how many sides your polygon is, and repeat, which tells you how many of the polygons to repeat. So in this example we've got 3 sides, so it's a triangle, and we've got 3 triangles. Now as you can see, these blue blocks show us the variables that we have in our Polygoner program. There are 2 user variables, sides and repeat, and those are user variables because we've got variable monitors on the screen with sliders, which means the user can change the values. And then we've got program variables, which are variables used inside the program, which generally speaking the user can't see. And that is size, so the size of the triangles. As you can see, we draw 10 little triangles inside the big one. The color, we choose different colors using the randomize function. And the rotate. Okay, how we figure out how much to rotate our triangles to get them spread out evenly in a circular fashion. We've also got program constants called the shape count. In this case it's 10 little triangles, and the size increment, which says how big each of the triangles are compared to the previous one. In this case, the smallest triangle has 5 on a side, the next one is 10, 15, 20, and so on. Now, to make things easier to read, I've underlined all the variables in all the places they appear on the slides. So if you see a word that's underlined, you must know it's a variable. Now, the best place to start with Polygoner is to go and create your 5 variables: your size, your repeat, your size, your color, and your rotate. The first 2 should be in the program that you load up already, but the other 3 you will need to go and create yourself. If none are there, then go and create all 5 of them. They are all global variables, which means they're available to all sprites. Okay, this is the code we went over last week. We've got a custom block called DrawShape, which I've shown is a custom block by putting a dotted line underneath it, and it has 3 parameters: start angle, color, and size. These are the parameters for your DrawShape custom block, and I've put dashed lines under them so you know where these variables get used. So start angle gets used there, color gets used there, and size gets used there. Size, as you can see, is used in 2 places, and this isn't one of the parameters. It is one of the global variables which we have access to. Now, something to note, alright, when you set the pen color to a color, there are 2 set pen color to blocks. The first one says set pen color to, and then shows a little square with a color in it. The second one says set pen color to, and puts a circle with a number in it, normally 0. If you want to use set pen color to a color, where your color variable is a number, you must use the second block. If you use the first block, after you put the variable in the space, it'll look exactly the same, but the first block won't change your color for you. Only the second one will change it when you put a number in using a variable. Okay, as I said, we covered this last time, so I'm not going to go through it step by step. We will jump straight to the code in the next slide. One thing to note, however, when you are putting your variables into your custom block, make sure that the ones you put in when you're calling your custom block, in DrawShape in this case, are the same as in the same order. The order is very important, as we'll see shortly. Okay, this is the code you should have got from going through the previous slide. Just to go back, one thing to note, you will see here we have got some indentation. These 2 lines, move size steps and turn clockwise, are indented from all the other lines. That means these 2 lines must go inside the repeat block. Okay, that's very important to note, and we'll see it on the next slide. There we can see the move size steps and the turn are inside the repeat block. That's what our indentation means. So as I mentioned, on the left here we've got our 5 variables: color, repeat, rotate, size, and sides. Only 2 are visible to the user: repeat and sides, and we do that by checking the checkbox here, which puts a variable monitor on the stage. As you can see, we've got our size, angle, and color. Okay, we use our variables by dragging them from your custom block into the blocks inside your custom block. So we dragged angle over here, we dragged color over here, and we dragged size over there. You'll notice that these variables have a purple background, not the usual orange one. That means that they are part of your custom block. These orange ones here are the same as your global variables over here, and they don't come from your custom block. If you have just done this code here and you run your program by clicking on the green flag, it's not going to do anything, because you need to call this custom block using some other code. So the easiest way to do that, so if we want to test it, is to drop a when green flag clicked onto your script area, and then drag the custom block calling block beneath that. And here we type in some manual values for size, start angle, and shape. If you do this and then click on your green flag, this would draw one shape of this size on each side, starting at this angle and of this color. But to make sure that this works, you need to make sure that your sides have a value bigger than 0, and your repeat has a value bigger than 0. So just make sure on your stage where those variable monitors are with the sliders that you go and set your repeat and your sides to values bigger than 0 before you try this test block. Okay, let's hop over to the next section, which is the main code. As I mentioned before, we have covered this in the video of the last lesson. Points to note, we've got some variables: size, global variable; rotate, global variable; color, global variable; and repeat, global variable. Okay, and then we've got two sets of indentation here. So all these blocks here are included in this repeat 10 block, and only these two lines are included in this repeats block. As I mentioned, it's very important to pass the values through correctly. So rotate must go with your start angle, okay, and your color must go in the right one, and your size must go in the right one. If we've done this correctly, then our code should look like this. We've got when green flag clicked, clear, because we want to clear the stage before we run it every time. Pen up to make sure we don't draw on the stage while we're moving the pen around. Set the initial size of your polygon to 5, then we repeat 10 to draw 10 of the polygons. We set the rotate to 0, set the color to a random value between 1 and 250. We go to x0, y0, which is the middle of the stage, and then we repeat however many times the user set on the variable monitor for us to repeat the shapes. Then we call our DrawShape block, okay, with size the size, start angle rotate, and color color. After we've called this, we go to the next line, which is called change rotate by 360 divided by repeat. That moves our sprite so it's pointing in a new direction, ready to draw the next polygon. And when we finish this loop, we change the size by 5 to make our polygons bigger, and then we go back into the repeat by 10 loop. To get a really good feeling of how this code works, I suggest you load it. It is on our website from the lesson 10 page, and you can see what happens on your screen. Okay, on to some new theory for today. Alright, the title here is You Ask a Lot of Questions. Normally when we're talking to someone, we don't ask them just one question. We ask them follow-up questions. So in this case, we've got a set of questions. The first one is pick a number, which is shown as using an ask and wait block. The answer that we type in gets stored in the blue answer variable. And we want to know, is this number that we're going to provide greater than 0? So we do a greater than block inside the if block. If that's true, we go to the next if then block. And then we check if it is not divisible by 2, or sorry, if it is greater than less than 10. If the answer is less than 10, then we go to the next block. And to check if a number is divisible by 2, we went over this in the previous lesson, we say answer mod 2, which says take your number, say it's 5, divide it by 2, and that'll give you an answer of 2 remainder 1. Only if the answer or the answer of this mod block is 0 do we know that the answer is divisible by 2, and then it's an even number. If it's an even number, then we'll execute the code inside here, which you see there isn't any. If it's an odd number, then it goes to the else, and it'll say bingo. Alright, and it has met all the criteria. The number is greater than 0 and less than 10 and is not divisible by 2. But wait, we've got another condition. It says or is a prime number. Now you'll remember a prime number has only two factors, two numbers that can go into it. Okay, the numbers are 1 and the number itself. So examples of prime are 3, 5, 7, 9, 11, 13. Not all odd numbers are prime, but most of them are. Alright, so we've got a little pretend custom block here which checks if the answer is prime, and if it is prime, it sets this global variable called isPrime, which is a flag, to 1. So then we do another check. If isPrime equals 1, then we say bingo as well, because then our number will be prime, which will meet the conditions as well. This might look a bit confusing, and it looks like there's a lot of code here. We can simplify it down using our AND, OR, and NOT relational operators. And this is what it looks like if we simple it down. So we use an AND block, an AND block, a NOT block, and an OR block. Now this looks a bit complicated, and we're going to go and show you how to put this together. But it is doing exactly the same thing. It's picking a number, checking if it's prime, and then it's doing all these questions here, actually these four, in one line. And we're going to cover how that works in the following slide. First of all, let's go and look at our operators. We've got the AND operator, which takes two parameters. We've just called them X and Y in this case. And we know that these hexagons are Boolean values. Boolean values can only be true or false, 1 or 0, yes or no. In this case, we're using true and false. So we're saying if X is true and Y is true, then the answer is true. If X is true and Y is false, then the answer is false. If we swap it around, if X is false and Y is true, the answer is still false. And lastly, if both of them are false, X is false and Y is false, then the answer is false. So you can see in the case of the AND operator, the only way you get a true value is if both your parameters or your inputs are true. Any other combination will give you a false. Now we'll show you how this works later. It might seem a bit arbitrary now, but it is an important part of computer programming. The next operator we're going to look at is the OR operator. Again, it uses hexagon blocks, so we know we have to put Boolean values in. 1, 0, true, false, yes, no. And the answer is also given by the shape of the block, which is also a hexagon. So it's going to give us a true or false answer. So if we look at the values again, X true, Y true, then the answer is true. If X is true or Y is false, then the answer is true. Or if X is false or Y is true, then the answer is true. And if Y is false or X is false or Y is false, then the answer is false. So you can see the OR operator is very different to the AND operator, because you get a true for every combination where at least one of your input values is true. You will only get a false if both values are false. The NOT operator. This one seems a bit weird. Basically what it does is it inverts or gives you the opposite of the input. So if your X is true, it will give you a false. If your X is false, it will give you a true. So it does the opposite. You can think of it in the same terms as either or neither nor. You can see this one is the opposite of this one. So either or will give me one or the other, neither nor will give me neither, none of them. This one is quite useful, the NOT operator, as it can be used to make some expressions in your programs simpler by using the NOT operator, as we'll see in a forthcoming slide. So back to our example. This is what our block breakdown actually looks like. So if we pick a number and we put the answer into the blue answer variable, we first check is it greater than 0 and less than 10, and then we put those blocks as parameters into an AND block. Then we go and check is our answer not divisible by 2. So we first go and see if it is divisible by 2. So answer mod 2 equals 0 will tell us if it's divisible by 2. So if this is true, then it is divisible by 2. If it's not, then this is false. So we want to change our false into a true, so we use the NOT block. And then, as I said, we do our test to see if it is prime, and if prime is equal to 1, we put that in there, we put the black block in there, and then we put the result, the purple block, into there, and then we have our example. So let's go and build this in Scratch quickly. So first of all, we're going to define a variable called isPrime. Okay, it's not important how this variable gets its value. We're just going to put it in so we can use it. Then we're going to our operators, and we are going to say we need to ask the question, enter a number. Remember, the answer gets put in the answer block. So we go back to our operators and we go and say, is our answer greater than 0? So go get our answer, put it in there, make it greater than 0. We also want to know, is our answer less than 10? Alright, and we want to put those together in an AND block. So we go get our AND block and we put them in, and you see the block grows to make space for them. Then the next thing we need to do is we need to go and figure out if our answer is even. So the easiest way to do that is we go and take our mod, take our answer, put it on the one side, put 2 in there, and then we go and check if that is equal to 0. But we don't want to know if it's even, we want to know if it's false. So we use a not block to switch that around. So there we've got our checks, and then we also need to go and check if our number is prime. As you remember, I created an isPrime variable, so we are going to say if isPrime is equal to 1. Now we need to join all these blocks together. So we need to say, if we go and have a look at our slide again, we've done the red block, we've done the black block, and we've done the green block. So now we need to join the green block with the black block to make it a purple block using the OR operator. So we go and get our OR operator, and we put that in the one side, put that in the other side, and now we need to join the purple block to the red block using an AND operator. So we go get our AND operator, put that in on the one side, and put that one in on the other side. There we go. And there we have our big block, which we would then go and put into our if then block. Okay, I'm not going to do all the code, but I'm just showing you how to build up your conditional test there. Alright, moving on. Okay, one more thing to note is there, as I mentioned before, using the not block can sometimes make things simpler. So if we go to back to our maths theory, we've got x is greater than and equal to 10. So if we look at this on a number line, if we have a solid dot over a number, it means it includes that number, and then the line shows us everything else it includes. So in this case, it's saying x is greater than 10, but also equal to 10 because the dot is solid. So if we had to do this using the greater than and the equal sign, then we would do it this way. So the first test is x greater than 10. As you can see, the circle is open, it's not solid, so that means we don't include 10. So we want everything bigger than 10, 11, 12, and 13. So that covers this, that covers this side. Then we're going to cover this side, and we're going to say x is equal to 10. Solid dot on the 10 means it includes 10. And we put these two together with an OR statement, which gives us our solid dot and the arrow to the right for everything bigger than 10. So that gives us an easy way to do that. But as you can see, I had to use 1, 2, 3 green blocks to do that. Another way to do it is x greater than 10 means everything that is not less than 10. So if we say x is less than 10, so the open circle means we don't include 10, and the number is going to the left, so everything less than 10, then everything greater than equal to 10 would be not x less than 10. It might be a bit confusing, but if you play around with it a bit, I think you'll discover it's quite a powerful trick. Okay, so we've got another exercise. Okay, we are going to enter a number between 10 and 90 and call it x. This is going to be the starting number. It's going to be for a game between you and the computer. What you're trying to do here is choose numbers on either side of x. You're going to choose numbers below x. The computer will choose numbers above x, and then we will see who has the number that is furthest away from x. So then the computer will pick a number between x and 100. So anything larger than x and less than 100, and we're going to call that value 100. Remember, the computer doesn't need the ask and wait block because it's not a human. So we can do that in code using the random function. Then we're going to ask the human, the user, the person using the computer, to pick a number between 0 and x. Call it user. Remember, the underline means these are variables. And then we're going to do some tests. If x minus user is greater than computer minus x, then you win. If x minus user is less than computer minus x, then the computer wins. And if x minus user equals computer minus x, then it's a tie. So let's go and do some code. So we'll go File New, don't save, start off with on green flag clicked, and then we're going to ask the user to enter a number between 10 and 90. Pick a number between 10 and 90. And remember, the answer goes into the answer block. And we need to save that answer, and we are going to call it x. Okay. And then we might as well create our other variables while we're here. We're going to create a computer variable, and we're also going to create a variable called user to store the user's answer. The computer's answer goes into computer. Now the computer needs to choose its answer, which must be less than x. So let's store x first. Go get our answer, put it in x. Then the computer must go and choose its answer. And we're going to use the random function. And it must pick an answer between x and 100. Now the user needs to enter an answer as well, and we have to use the ask and wait to get that. So we're going to say enter a value between, so now we have to use the x. So we're going to have to use our join function that we learnt about in a previous lesson, and we're going to actually take this out and put it in here and say enter a value between 0 and, remember to put the space there, and our variable x. And we're going to put that in the block there, and then we're going to store whatever the user chose as an answer. Okay, so now we've got all our variables. Now we need to do our checks. So we need to check if x minus user is greater than computer minus x, and the similar thing here, except it's a less than, and then the third one is the equals to. So we can create one block and then duplicate it and just change the signs to get the other three blocks. Then what we need to say, if the condition we're testing for here is true, is then you win, or the computer wins, or it's a tie. So let's go and do a if then block. We're going to need 3 of them. Okay, now we need to work out our conditions. So we are going to say we need to use our maths blocks. So we need to use our variables, and we need to use our greater than. So let's go to our variables. So if x minus user is greater than computer minus x, then we put it in there. But let's go and get our other operators first before we start plugging things in. So we need a less than, and we need a equals to. And now we can go and duplicate those. and duplicate, and then we plug them in. And now we plug these, see, it's easier to grab it by the middle into there. And now we need to go and give some feedback. Using our duplicate to make things go faster. If x minus user is greater than computer minus user, we're going to say you win. If it's the opposite, then the computer wins. And if it's the same, we can say it's a tie. Alright. Now as you can see, we've got all our variable monitors, because by default when you create a variable, it checks this box to show you your variable monitor. So let's run our program. Pick a number between 10 and 90. Let's say 50. You can see the computer's chosen 84. We're going to choose 30. Now 50 minus 30 is 20, but 84 minus 50 is 34. So the computer is going to be bigger, so if we press enter, it's going to say the computer wins. If we try that again, pick a number between 0 and 50, enter 50 again. Okay, we can see the computer picked 83. So 50 minus 83 is 33. So if we pick 50 minus 33, which should give us 17, then we should have a tie. It's a tie. Let's try one more. Pick a number. Let's say 70. The computer's chosen 81, so the difference between 70 and 81 is 11. So let's choose 10. And now you can see you win. It's a pretty basic example. We just wanted to get you using your greater than, less than, and equal to blocks. Okay. And we think we've achieved that. Okay, now dressing up Tera. Dressing up Tera is one of the projects we gave you on lesson 10 to see how much you'd learned in the course so far. Some of you managed to finish it, some of you didn't, but there's quite a lot in it, so we're going to go through it step by step and explain everything to you. So the first thing to note is that there are 8 sprites in this project, which are Tera plus her 7 clothing items. We've got the hat, the antenna, the glasses or goggles, the blouse, the t-shirt, the wings, and the cape, and of course Tera herself. Now, some clothing items must appear in front of Tera, some of them must appear behind Tera. The wings always appear behind her, and the cape, the antenna, the eyes, the hat all appear in front. But the order in which they appear in front doesn't really matter. All we have to do is make sure when we add them that they go to the front. So if you click on the hat first and then on the antenna will go on top of the hat. If you click on the antenna first and then the hat will go on top of the antenna. Okay, the other important thing to know is that the centers of all the clothing items are not the same as Tera's center. So if we made the clothing items travel and stick on top of Tera exactly on her center, we'd have some very strange looking clothing. For instance, the t-shirt, which has a middle roundabout there, would go on the middle roundabout there. So it would cover half her face and half her body. So we're going to talk about relative positioning to get that to work out correctly. Then we must also notice that if we move Tera around the stage by clicking on her with the mouse and moving her, then we must get the clothing that we've added to her to follow her when she moves. And we're going to go over how that works. Okay, so as I discussed, layers, the clothing needs to appear on the right layer. So we said the only sprite that goes behind Tera is the wings, everything else goes in front. Okay, and we get to use the layer commands, go to front and go back one layer. All the clothing items except the wings can use the go to front command, all the wings can use the go back layers command. Now by default the layers that it goes back is 1. In this case we are going to go back 5 layers, just to make sure that the wings go behind Tera. Now relative position, as I mentioned, there's the center of Tera, more or less in the middle of her face. There's the center of the wings. If we put the center of the wings in the center of Tera, then her wings would be around her head. So we don't want to do that. So here I've done an overlay of the wings and Tera, keeping in the center lines. There in the red circle you can see is the center of Tera. Here is the center of the wings. So we can see the centers don't fall on top of each other. Note that this horizontal lines are the x-axis and the vertical ones are the y-axis. So in this case the x-axis for the wings is 35 steps down from Tera's x-axis, and the y-axis for the wings is 5 steps to the left of Tera's y-axis. So the way we're going to do that is we're going to use the glide, and then we're going to use a minus operator to minus the 5 and minus the 35 on the x and y respectively, and then we're going to use this new block, because remember the position that was in a sprite, if we go and have a look at motion, remember we've got x, y position, and if we move our cat around they change. That position or that variable can't be read directly by other sprites. So what we need to do is we need to use this new block in sensing, which looks like this. And as you can see, it has x position, y position, direction, costume number, costume name, size and volume of whatever sprite you have in your project. So what we're going to do is we are going to create a new project. Don't save. In fact, we're actually going to go load up the Tera project without any code in it. It's not in here. Let's try lesson 10. Okay, Tera no code. Alright. Okay, and apparently it does have a bit of code. Alright, so we're going to delete all the code that has accidentally made its way in here, because we are going to create it from scratch. Excuse the pun. Alright, so there we see all our 7 sprites plus Tera, making 8 sprites, and there's Tera. So if we go into the mask, we are going to use a glide. Okay, I'll explain why we're using a glide just now, and then we are going to use our operators with our minus. We need 2 of those, and then we are going to use our new special block, which gives us access to the values of other sprites, and in this case we're always going to choose Tera because that's who we're interested in, and we're going to use that block again, and now we're going to choose the Y position and put it in there. Alright, now I haven't filled in values here because we're going to get to those now in the following slide, but as you can see we put in 5 and minus 35. So here is the picture of more than just the wings as an overlay. As you can see, none of these lines fall on top of the center line of Tera, which is the dark one here. So we have to use offsets for all of them. Tera doesn't have any offsets because she's not a clothing item, but all the other clothing items have offsets. So we're going to put these values into these placeholders here to make sure that the clothing item glides to the correct spot. Alright, now as I mentioned, we need to make sure that when Tera moves, by us clicking on her and dragging her around the stage, that any clothing items we've already added to her must follow her. Now we need to know if we've added a clothing item to Tera, and the way to do that is to have a variable on each sprite which says whether or not it is on Tera. We're going to call that variable Latched, okay, and as you can see it's got the name of the sprite in front. That's very important because that means it's a local variable. Only that sprite can see that variable. And by making it a local variable, it means we can have every sprite have that variable and they won't overwrite each other's values. So the easy way to know if we've added the sprite to Tera is when the sprite is clicked, we set the latched flag to true. Otherwise we set it to false. Okay. Right. Then we also need to know when Tera is moving. Okay. When Tera moves, her X position and her Y position will change. Now see, I've underlined these. These are variables. Okay. The X position and Y position are system variables. They're variables that belong to Tera. So we won't go and create them. You'll see they're blue and not orange. But we will create an old X and an old Y orange variable. And the reason for that is the easiest way to figure out if something is moved is record where it is now and then check again in a little while and see if it's still in the same spot. If it's not in the same spot, then it's obviously moved. If it has moved, then we are going to broadcast to all the clothing items sprites that Tera has moved. This will make more sense when we see the code in a few minutes. Okay, now we've spoken about top-down and bottom-up design. In the Polygoner example it was bottom-up design because we could create the shapes and then build on that. In this case it's top-down design because Tera is driving everything. When she moves around, she's the one that the clothing needs to follow. We've also got 8 sprites all with their own code in. Okay, the code for the clothing items is only different by the initial position, as in where you find them on the stage where you start the program, the layer that they need to appear on, and their glide XY offset, which is these values here, which we'll copy onto the slides that we use in the future. Okay, so we can do the code for one of the clothing items, copy it onto the other sprites that are clothing items, change a few values, and hey presto, we've got that code done. Alright, but on each clothing item sprite there are 4 parts. There's an initialize part, which happens when we run the program. There's a sprite clicked part, which we saw already over here. Okay, there's a few more code blocks that go underneath this. There is a when I received Tera moved. Okay, we spoke about checking if Tera's moved, and if she does, she sends a broadcast. And then we have a go to Tera custom block, which actually gets the clothing to go to Tera and follow her if she moves. Now the reason we're using a custom block here is because we are going to do the same thing when the sprite is clicked or when Tera moved broadcast is received. So instead of doing the same code twice, we just create a custom block which we're going to call go to Tera, and we call that from both of these code blocks. So let's get started. Alright, this is the code that we should have for Tera. So let's go to Tera. We're going to set when green flag clicked, and then we're going to go to these coordinates. So let's go to Tera, when green flag clicked, and go to XY. And the values are -115 and -50, which happen to be the default values. Then we're going to say, what should I wear for 2 seconds? So we're going to go to the looks, and we're going to say, what should I wear? Alright, then we're going to have 2 variables, our old X and our old Y, which we need to keep track of where Tera is. So go create 2 variables, old X, these can be for all sprites, and old Y. Okay, now we need to go and set those variables, and we're going to set both of them. We'll do X first, and we're going to set them to the current position of Tera. So we've got the X position and we've got the Y position. Now we need to do a forever loop so we can go and check if Tera moves. That's the only thing we need to worry about Tera. Has she moved? So we're going to do a forever block, and then inside that we are going to do a if block. And then we need to build up our condition to see if she's moved. So if old X equals X position, not, which will give us the opposite, or not old Y equals Y position. So we're going to go to our operators, and we're going to go find our equals, and we're going to say, where's our variables? Old X equal to X position, and we're going to do the same thing for Y. Old Y equal to Y position, and we want to not them. So if they are the same, if old X equals X or old Y equals Y, then Tera hasn't moved, so the answer will be true. But if old X is not equal to X, then the answer will be false, and we want to turn that into a true, because then it means she will have moved. And we're going to put these together with an OR, because we want to know if either of those have changed. So the X or the Y can change, and then Tera has moved. So we put those together like that, and we put that inside our if block. Alright, and you can see it grew, and we can clean up, which will make our code nice and neat. Now if Tera moves, we need to let all the clothing sprites know. So we need to broadcast Tera moved. So we need to go to control, and we need to go to events, and we need to say broadcast message, and we're going to create a new message called Tera moved. Okay, and that will be received by all the clothing sprites, and then they can act on it accordingly. But because Tera has moved, we need to update our old X and old Y. So we don't need that, and we put those, where did we put them? With the broadcast. There we go. So that is the code for Tera. All done. Now let's go and pick a clothing item. Alright, we've still got this from our previous slide. Let's see what, as I said, that's what we should have. And now we need to do stuff for our clothing. So we're going to do two things: when green flag clicked, and we're going to define our custom block. So where's our events? When green flag clicked, go to choose an area on the stage not near Tera. So we don't want the clothing to start off on top of Tera. So we're going to go find our goggles, which are over there. And if we can look at the coordinates here, sorry, let's look at them on our sprite, 170 and 93. So we're going to go to XY 170, 93, and then we're going to set latched equals false, which is our variable which we don't have yet, which we use to know if we've added the clothing item to Tera. So let's make a variable, call it latched, and spell it correctly, and make it for this sprite only, because we're going to use the same variable for all sprites. And if we make it a global for all sprites, it's going to interfere with each other. As you can see, mask is in front of latched, so that means it's a local variable, but we don't want to see it on the stage. So we uncheck the checkbox, and then we want to set latched to false. Okay, and then we want to obviously show our sprite. Boom. So that is what's going to happen when we click the green flag. Then we are going to define our custom block, go to Tera, and it's not going to have any parameters, so we're not going to pass any values into it. So we go make a block, call it go to Tera, and you can see it created two blocks, this one where we define the custom block, and this one where we call the custom block. So the first one is to go to front. So looks, go to front, because remember the goggles go on the front of Tera, not behind her. And then we're going to glide 1 second to X position of Tera minus X offset, and Y position of Tera minus, that should be Y offset, sorry. Okay, and we get our values for our goggles, or our mask here. So minus 15 and minus 20. Alright, so we're going to put that there. And our mask, minus 15, minus 20. Put that in there. Minus 15, minus 20. Alright, so that's 2 out of 4 done. Let's do the next 2. Now, when the sprite is clicked, so we go to our events. When the sprite is clicked, we are going to set our latched value to true, because when you click on the sprite, then it has to glide to Tera, and then we have to call our go to Tera custom block. So we drag that there. Then when I receive Tera moved, the broadcast, we do the same thing. Okay, and this shouldn't be indented here. This is all on the same level. So we go and say set latch to, there we go, find our broadcast. When I receive Tera moved, set latch to true, and then we call our go to Tera. And that's all that our code needs to do. So if we neaten it up a bit, that's what we look like, and that's what we should have. Now we can copy. Oh, I made a mistake. Okay, what we need to do is we need to check if latched is true. Okay, so let's go fix that. We need to go and check, and we need to go and use our equals operator and go get our variable, which is latched, and we're going to check if it's true, and then if it is true, we're going to go to Tera. Okay, so that's what we should have. So when you click on the sprite, you always go to Tera and you set your latch to true. When you receive the Tera moved, only if your latched is true, so your sprite has been clicked on once at least, do you go to Tera. So, as I said, the code is the same for all sprites except for a few things. The first one is your initial starting position. The second one is where you go to on your layers. All of them except for the wings can go to the front. And then your offset values, which we take from the table which is on the slide. So let's copy all this code to the other sprites, and then we'll come and fiddle with the areas in the red blocks. So let's collapse our goggles, and now we're going to go put that on there, 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 and there. And if we look at our cape, okay, it's got everything on top of each other, but there we go. Okay, now the problem is it's dropped some of the code here, so we're going to have to put that back in. So let's go and do the same thing that we had on the mask. X position of Tera, Y position of Tera. Okay, and we've got 2 copies of the same thing here, which is a bit odd. Okay, so this shouldn't be when sprite is clicked. We need to go and create a custom block called move. We'll go to, whoopsie. Okay, let's go try that again. Go to Tera, no parameters, click that in there. go get our operators. We want two minus ones, and then we want to get our sensing and go get X position, and Y position, not of mask but of Tera. Okay, change that to Y, and we're going to put that in there, put that in there, and then because we're on the cape, we need to go and find out what the cape values are, which are 55 and 62. 55 and 62. Alright. Okay, the starting position of our cape, if we go look here, it's 107 and minus 50. 107 minus 50. Okay, we are going to the front. We put in the right values here, so that should work. So we have got two clothing items which have their code in them. Oops, see, that's where our Go to Tera landed up. And we should be able to run on the cape and on the mask. So let's test. Okay, we don't actually need to see our old X and Y, so we can uncheck those. So let's run. What should I wear? Click on the cape, goes to Tera. Click on the mask. Oops, that one's a bit off. Maybe it's supposed to be on her head. And then we move Tera, and they follow her. Okay. Now we can do the same thing for the wings, but the wings are a bit different. So let's stop our program, go to the wings, or copy the code from the others to the wings first. So 1, 2, 3, and 4. If we go to wings, there's 1, 2, 3, 4. Okay, wings are gonna, whoops, let's move our wings back, stop the program. Wings initial position is minus 114, or 114 and minus 64. 114 minus 64. And instead of going to the front, we are going to go back 5 layers to make sure that Tera has her wings on her back and not on her front. Okay, so if we run the program now, okay, and we click on the goggles, they go sit on her head, we click on the cape, goes on her back, and we click on the wings, and they go behind Tera. Okay, we didn't update the offset values here, so the wings should be 5 and 35. So let's go change our values here, 5 and 35. Stop our program, start it again, click on cape, click on goggles, click on wings, and now we see they're in the right spot. If we move Tera, then all of them follow her. Alright, and the same thing is true for your other sprites. So you can copy your code from your other clothing items onto the other sprites, the hat, the blouse, the t-shirt, and the antenna. Make sure you adjust your offset values. Make sure you have a go to front here, and you go and set the initial position, and then you should be good to go. Alright, so that's what we should have on every sprite. Make sure to go and check that value, that one, and that one. Alright, that's the end of this lesson. Remember, your homework is to work on your project. For more information on our last lesson, go look on our website at lesson 11, and we'll have the information including this video up on Monday for lesson 12. Next lesson, we are going to cover lists. Lists are like collections of variables. Here you can see we have a list called days, and it's got 7 areas to store values in it, and we put the names of the days of the week in it. This is very useful in programming, gets used all the time, and I think you'll find it useful for your project. As always, please shut off your computer before you go, and don't forget to take your flash drive home with you. Thank you for coming, and we look forward to seeing you next week.